Let us see the type of parsers. Parsers are also nothing but a syntax analyzer. So at the syntax analysis phase, we use the software parser. Parsers are basically of two types. One is top-down parser and other is bottom-up parser. And top-down parsers are again of two types. So coming to this point, various textbooks have various conventions and they follow various methods, and I am following this. Maybe in that book by Aho Ullman Ravisetti, the compiler's book, the Dragon book, they follow a different convention. You can follow anything, but I am following this. So top-down parsers are of two types. One is top-down parser with full backtracking and the top-down parser without full backtracking. So what do I mean by backtracking is we try to go and analyze all possibilities, and then if any of the possibility is wrong, again we go back and choose the next possibility. Okay, and top-down parsing without backtracking is we are going to generate the string exactly that is required. Okay, and bottom-up parsers. Bottom-up parsers are again of two types. One is operator precedence parser and other is LR parsers. Bottom-up parsers are also called as SR parsers. SR means shift reduce. What is shift is, if you use a stack, generally shift is pushing and reduce is popping. Okay, and there is operator precedence parser, which will talk about it, and there are LR parsers. And why it is called LR parsers is, L means we are scanning the string from left to right, and R means we are using the reverse of rightmost derivation. Okay, and LR parsers are of these four types. And coming to this top-down parsers without backtracking, one is called recursive descent. The name recursive descent is given because we are going to write recursive functions for every production, and the other is called non-recursive descent. Whatever it is, this LL1 is these two parsers. If you have to construct them, the mainly top-down parsers without backtracking, first of all, grammar should not have left recursion. So in order to construct this class of parsers, grammar should not have left recursion, and then the grammar should not have any kind of non-determinism, which means non-deterministic grammars are not allowed, and left recursive grammars are not allowed. If you find any grammar which is having left recursion, you have to eliminate it, and if you find any grammar which is having non-determinism, you have to left factor it. Okay, so then any parser, if you have to construct it, you should not use any ambiguous grammars. Therefore ambiguous grammars are not allowed for any of these parsers except one parser, operator precedence parser. Operator precedence parser is the only parser which can even parse ambiguous grammars. Okay, so I'll tell you what is the basic difference between top-down parser and bottom-up parser by taking an example. Let's take this example of this grammar and then see what is the difference between top-down parser and bottom-up parser. Any parser, the main use of any parser is, given any string and given any grammar, it has to check whether this string can be generated from this grammar by using a parse tree. If we could construct a parse tree by using this grammar to generate this string, we can say that yes, this string is generated. And now there are two ways in which we could construct a parse tree. One way is I could start from the starting the start symbol and I could generate it like this. If I start from the start symbol and generate it, now the main decision is at every point what is the production I should choose. Let us say at this point there is no confusion, only way I have is use this production. Now at this point I could either use this production or this production, that is the choice I have to make. Okay, so I am making the choice of the first one. I am choosing the first production, and then A is going to B and B is going to D. Okay, so if you observe this, what we did is I started from the start symbol, and at every point I am making a decision about what is the next production I should be using, which means whether I should use this production or this production. Therefore the main decision coming to top-down approach is starting from the start and going to the basic terminals. The main decisions that we have to make is at every point, at any point, if I have two productions, which one to choose. If I could make the decision, it is fine. Therefore, the main decision making is what is the production I should choose for a variable, right? So that is why we need to be very deterministic in this. Next one is bottom up parsing. Bottom up parsing is I'll take the terminals and then I'll go to the root. For example, if the word is A, B, B, C, D, E, if this is the word, I'll start from the terminals and then I reach the top. So what is the terminal? A, B, B, C, D, right? So initially I am going to convert this to B to A, and then I am going to convert this to A, B, C to A. See, this is the production I am using, right? And then I am going to convert this D to B, and then I am going to convert A, B, E, this entire thing to S. Therefore, if you see the way I built it, I started from the terminals, the string, and then I reached the top, the start symbol. That is why it is called bottom up parser. Now coming to the bottom up parsers, the main decision I might have to make is, if I see any terminal, should I reduce it or not? When to reduce? Here, what to use, which means if I have more than one alternative for a production, which alternative should I use? That is the main decision I have to take in top down parsing. And coming to bottom up parsing, if I have when I am just parsing it, when to reduce, right? So here the main task of bottom up parser is when to reduce, and the main problem with top down parser is what to use. If you have more than one production, what to use, right? And here if you have more than when to reduce and what is the production that I should use. So if we can solve these two problems, we can actually solve, construct parsers. Then one more thing worth noting here is, if I look at the top down parsers, they work in such a way that they are following leftmost recursion, that leftmost derivation. The way which we used here is, S will derive A, B, E, isn't it? The first production that I used is this, and in the past the second production that I used is this A is replaced with ABC, which means A, capital A, small b, small c, capital B, small e, and again this A is replaced with B, A, B, B, C, B, E, and again this B is replaced with D. So if you look at this way, we did it exactly in the leftmost derivation manner, which means if I have more than one variable in the sentence, I am always going to expand the leftmost variable first and then going to the rightmost. Therefore, top down parsers will also use leftmost derivation. Coming to bottom up parsers, let's see how this one is behaving. So first one I reduced is, this B is reduced to A, and then ABC is reduced to this, and then D. So if you see this, it is a kind of bottom up parser is kind of S derives A, B, E, okay. And now what is the right, let's see the rightmost derivation. In the rightmost derivation, what we get is A, this B is going to be expanded with D, DE, and again this A, B, C, D, and again this A, B, B, C, D. So this is nothing but rightmost derivation, right? So this is the leftmost derivation, this is the rightmost derivation. And now if you consider the way we have built this tree, the way which we have, using which we have parsed it, we are actually using a reverse of rightmost derivation, which means I have taken the string, in a reverse way. So reverse of rightmost derivation is like this. So I'll take the first thing that is reduced is this one, B is reduced to A, isn't it? And then ABC is reduced to B, A, B, C is reduced to A, and then D is reduced to B, D is reduced to B, and then A, B, C, E is reduced to S, right? So the way in which we build the bottom up parsers is in the reverse of rightmost derivation. The way in which we build the top down parsers is in the leftmost derivation. So top down parsers follow leftmost derivation and the bottom up parsers follow rightmost derivation in a reverse order. It also called as reverse. The reason is we are not actually deriving the string from the start symbol, we are deriving the start symbol from the string. Therefore, it is reverse process. Let's talk about LL1 parser first. So in LL1 parser, the name LL1 is given because the first L means we are scanning the input from left to right. From left to right. That is the meaning of the first L, which means if I have input A, B, C, D, something like this, I'll scan it from here, from the leftmost symbol to the rightmost symbol. I'll not scan it from the other side. And the second L means I am using leftmost derivation. So in the process of deriving the parse tree, we are going to use leftmost derivation. And this one means number of look aheads. Look ahead is nothing but how many symbols are you going to see when you want to make a decision. Generally in LL1 we are going to take only one symbol, so that is why the look ahead is 1. And if you look at any general parser, it is going to have all these components. First component is LL1 parser, which means the parsing algorithm, which will talk about what we should be doing, about what are the action that we should be taking, that is about the parser. And second is LL1 parsing table. Parsing table means it is a data structure which we shall construct using the grammar, given grammar. And then we shall use a stack. Stack is a data structure which is used for the procedure of parsing. And then there is input buffer. So inside the input buffer we'll have the input, and generally the bottom of the stack is having always dollar, and then the end of the string is always going to have dollar. These two dollars are used just to guess when we should stop. So the main thing is, if you have to construct a LL1 parser, you should construct the LL1 parsing table. How to construct the LL1 parsing table is, given a grammar, we should construct it. I'll just tell you how the procedure is. Before going to construct a LL1 parsing table, we should know two functions. One is first and other is follow. First is nothing but if I start with any symbol and generate all the strings from it. For example, if I have S derives, the production is A, B, C, D, something like this, a grammar. And then A derives small b, and then B derives small c, C derives small d, D derives small e. If I have a grammar like this, if I start from A and I try to derive all the strings, in all those strings what is the starting symbol, which means if I start with S and I start deriving all the symbols A, B, C, D, in all the strings that you get from this, what is the starting symbol? It is always going to be A. Therefore first of S is A. The reason is, whatever strings you derive, always there is going to be A, and whatever happens after this, that is, you need not worry about it. The start symbol is always going to be A. If I start with capital A and derive all the possible strings, here I get only one possible string. What is the starting symbol in that? B. Therefore first of A is B. What about first of C, first of B? First of B is, if I start deriving everything, I am going to get only C. Therefore first of B is C, and first of C is D, first of D is E, right? So that is how you can find out the first. Let us say here, instead of this A, I don't have A and I have this production S derives A, B, C, D. Now what is first of S? If I start deriving all the strings possible from S, I'll start like this: S derives A, B, C, D, right? And then now A is going to derive small b. So always whatever all the strings that are derived from this B, C, D, I don't care about it. Always S is going to derive the string starting with B. So in this example, first of S is B. In case if you don't have A, let us say I have epsilon here, B or epsilon. Now what is first of A? A can derive B or it can derive epsilon. Therefore first of A can be either B or epsilon. Now what is first of S? First of S is, if I start with S, I can derive A, B, C, D, and now A can derive either B. If that is the case, then first of S is B, or A can derive epsilon now. In case if A derives epsilon, which means this A will get vanished. Now S is going to start with B. Therefore first of S is C, right? So in case whenever you get any epsilon, you go and substitute in that position and then see what is the remaining string. From that string you have to find the first of it. So that is what is called first. So what is the definition of first is, if I have a variable or a string, from that variable if you try deriving all the strings, whatever is coming in the beginning, the first symbol, the first terminal is also called as first of that string. In this case, if I want to find out first of s, you have to derive all the strings from s, and whatever is in the beginning of those strings, that is called the first, right? And next one is follow. Follow means what is the terminal which could follow a variable in the process of derivation. Again, what is the terminal which can follow a variable in the process of derivation? For example, I am always going to start my derivation with s followed by dollar. The reason is, always input is followed by a dollar. Always in the input, let us say if the input is a, b, c, d, always we are going to start with a, b, c, d dollar. Input is always being followed by dollar. Therefore, when we start the derivation, we always start it with dollar at the end. So s is always followed by dollar. Follow of s is always dollar. And now let us say s is being derived with a, b, c, d. A, b, c, d. Now what is follow of d? Follow of d is dollar. Now let us assume that I am replacing b, capital B, or let us say capital C with d. If I replace capital C with d, then I am going to see b is followed by d. Therefore follow of b is d. So if you want to find out follow of a variable, you have to find out what are all the terminals that are following that variable in the process of derivation. But then it is going to be somewhat difficult in order to do this way. So one other way is, you need not actually derive the strings and see the follow. Instead of that, you could look at the productions. The reason is, every string is actually formed using the right hand side of the productions. Therefore you could see the right hand side of the productions and then guess what could be follow of what. Let us say the grammar is s derives a, b, c, d. Now what is the follow of s? Always remember, follow of start symbol is going to contain dollar. Yes, so follow of s is, one thing is we have dollar, follow of s is dollar, as well as if you see s in the right hand side of any production, then you have to consider that also. But then s is not present in the right hand side of any production, therefore you need not worry about it. For now, follow of s is dollar. What is follow of a? Follow of a is, see wherever the a is in the right hand side, a is here. Therefore there is a chance that when you are deriving a string, you are going to get a here and then followed by b, c, d. Therefore follow of a is nothing but first of b, c, d. Whatever this b, c, d derives, in that whatever is in the beginning, that is going to follow a. So what is first of b, c, d? First of b, c, d is nothing but first of b. What is first of b? First of b is c. Therefore follow of a is c. What about follow of b? Follow of b is first of cd. What is first of cd? First of cd is first of c. What is first of c? C derives d. Therefore follow of b is d. Right? And what about follow of c? Follow of c is whatever is first of d. Now what is first of d? First of d is e itself. Therefore follow of c is e. Now what about follow of d? There is nothing following d, right? If there is nothing following d, should I write epsilon? Remember this, follow will never contain epsilon. The reason is, if nothing is following a variable, obviously there will be a dollar, because we are always going to start the derivation with s dollar, isn't it? Since we are starting the derivation with this s dollar, if nothing is following a symbol, then definitely there will be dollar at the end. It doesn't mean that if there is nothing in the end, there will always be dollar, right? So there are some cases. If I have a production like this, see this, if I have a production like a derives bc, right? Then what is follow of c? Follow of c need not be dollar. Follow of c is follow of a. The reason is, in the derivation process, let us say somewhere I got capital A, small a, b, c, dollar. This is the string I got in the derivation procedure. Now we are going to replace a with this bc, right? If I replace this a with this bc, then what happens is, whatever was previously following A will now follow C. That is why if there is nothing at the right side of a variable in the right hand side, then always follow of that variable is follow of left hand side. The reason is, in the process of this expansion, we are going to expand it in such a way that the left hand side is going to be replaced with right hand side. Therefore, whatever was following left hand side will now follow the rightmost symbol of the right hand side, right? So there are two exceptions. First thing is, in the first we get epsilon, and in follow we never get epsilon. If there is nothing to the right of a variable, it doesn't mean that we have to always write dollar. You have to check the left hand side, right? So I'll take some examples and then I'll explain you what is first and follow. Okay.